Hello class, welcome to today's class. Today we're going to learn on how to construct the figures of the same area. How to construct figures of the same area. So these figures, we have a triangle. Triangle number 1. This is your triangle. And then we have number 2, we have rectangle. This is a rectangle. And then number 3, we have square. And this is your square. So we all know that area of a triangle is a half base times height. Area of a rectangle is length times width. And then area of a square is L times L, which is L squared. So we have here is length, here we have width, you have this one is your height, and you have here is your base. Now, for us to construct now, sometimes you can be given a triangle and be asked to draw a rectangle of the same area as the triangle. So we are going to begin from triangle to rectangle. So you have this as your triangle. You are saying this is our height, this is our base. And remember we said that this is half, base, and height. Now we've been asked to construct a rectangle of the same area as this triangle. And you know that rectangle is length times width. For instance, if you have now your base, the base of your triangle is maybe 50 millimeters, and the height of your triangle is 40 millimeters. So it means that the area of this triangle will be half times 50 times 40. So here you'll have, this is 25 times 40, which is 1,000 square units. So for you to construct a rectangle of 1,000 square units, it means that you are going to eliminate this half, because as you can see we have 2 elements here, and we have here 2 elements but including the half, so it will be 3. So we are going to eliminate this half. So it means that for us to construct a rectangle of the same area as this triangle, we are going to bisect the height of the triangle. So it means that we'll draw a rectangle of the same base, which is 50, but we are going now to bisect this height into 2. We are dividing this height into 2 equal parts. So the half of 40 is 20. So the area of our rectangle will be length times width, which is 50 times 20, which is 1,000 square units. As you can see, we have 1,000 square units and 1,000 square units. So you can be given a rectangle to draw a triangle of the same area as the rectangle. So you can be having maybe your rectangle. Let's say here is maybe 80 and here maybe 20. So we know that the area of a rectangle is length times width, which is 80 times 20, which is equal to 1,600 square units. And now you've been asked to draw a triangle of the same area as the rectangle. So it means here that because in our triangle we have this half, saying that it is half base times height. So because we know that in our triangle we have this half, so it means that we are going to eliminate this half. So it means that either the length or the height, we're going to multiply it by 2. But taking our height, we can multiply our height by 2, so that if we multiply by half, we come back to 20. So we can have our triangle, we can retain this one our base is 80, but now this width, which is going to be our height, we are going to multiply it by 2. So if we multiply it by 2, we have here is 40. So it means that the area of our triangle will be half times base, which is 80, times height, which is 40. And as you can see, 40 times 40, we're going to have 1600 square units. So in this case, you'll be having 16 square units in your rectangle and 1600 square units in your triangle. So we'll be having now a triangle of the same area as the rectangle. So in our last, we'll have rectangle to square. Maybe rectangle to square. So for you to construct a rectangle to square, so you are given a rectangle and asked to draw a square of the same area as the rectangle. So assuming this is your rectangle, let's name it A, B, C, D. So the first step, you are going to extend line AB. You extend line AB, and then from there, one leg of your compass at point B, you open it to point C and draw this arc to form a sector. Now, the end of this arc, we can call it point Q. Now, you are going to bisect this line AQ. So maybe your line of bisection passes through that point. And then let me call here point M, the point of bisection between AQ. Let's call it point M. Now you're going to take point M as the center and open your compass to point A. Remember, AM and MQ are equal. So I'll stand here, open my compass to point A, and draw this semicircle. As you can see, my semicircle starts at point A and ends at Q. So from there, I'm going to extend line BC to touch my semicircle, maybe at point S. This is point S. Remember now, this point BS is one of the side length of our square. And we know that our square L length, all the lengths are the same or are equal. So far, we know how to construct maybe triangle to rectangle, rectangle to triangle, rectangle to square. Now, don't be surprised also to be asked maybe to construct a square of the same area as the rectangle. So you can say, a triangle to square. Triangle to square. So for you to construct a square of the same area as this triangle, now you'll be having a triangle, and for you to construct the square, it is not possible for you to go directly from the triangle to the square. So you'll have to construct first the rectangle. So you'll have the first step, you have the triangle. Then from the triangle, you'll construct the rectangle. And then from the triangle, now you'll have your square. You'll have your square as the final product. So you already know all these steps. So you'll be given a triangle, and then from the triangle you construct a rectangle, and then from the rectangle you'll have to construct your square. So in our next video, I'm going to show you how to construct a triangle, from triangle to rectangle, from rectangle to the square. That is now from triangle to the square. That is the old procedure that we've learned today.